Let's talk about chemistry. It feels like it's been a long time since I've gotten to talk about chemistry specifically, and it's a course that I absolutely love. I had so much fun writing my chemistry curriculum. I delight to talk to chemistry teachers. I just think y'all are a really special group of people, and I'm really passionate about the scope and sequence that I settled on when writing my chemistry curriculum after researching for months. I do not have a curriculum out there that is more research than my chemistry curriculum. And I'm really passionate about kind of what I settled on and how I decided to approach this lab science. That's a hard science that is required by a lot of districts as a high school graduation requirement. So it's interesting that it is that in so many places because it is so challenging. And so I think it's worth talking about how and why I teach chemistry, the scope and the sequence with which I go through. And then we'll kind of end the episode with what I think makes It's Not Rocket Science chemistry unique. In particular, for those of you who might be getting your contracts for next school year and you find out you're teaching chemistry for the first time and you're freaking out, I'm hoping this episode will encourage you that this is a really fun course you get to teach. And also there are options out there in terms of curriculum to support you. So let's dive in. This is Secondary Science Simplified, a podcast for secondary science teachers who want to engage their students and simplify their lives. I'm Rebecca Joyner from It's Not Rocket Science. As a high school science teacher turned curriculum writer, I am passionate about helping other science teachers love their jobs, serve their students, and do it all in only 40 hours a week. Are you ready to rock the time you spend in your classroom and actually have a life outside of it? You are in the right place, teacher friend. Let's get to today's episode. So for this episode, I'm going to outline my personal main goals for teaching chemistry that I think any chemistry teacher can adopt and make their own. I'm going to share the sequence that I settled on for teaching the content in the order that I do, and then also in the groupings that I do, because I do believe that you can actually do chemistry a lot of different ways and it be effective. But I'll kind of share the rationale behind my sequence. I'm going to share some themes also that are interwoven throughout all of my units throughout the entire year of chemistry. And then I'll end with a few things that make It's Not Rocket Science chemistry unique. So first, my main goals for chemistry when I wrote it is that I wanted chemistry to feel approachable and relatable for students, but also for teachers. I know a lot of teachers get thrown preps last minute and it can be overwhelming. Like you teach biology and you get environmental science, or you get anatomy, or you get AP biology. But that is not as scary because it's all under this umbrella of life science. What is scary is if you jump from, say, a life science to a quantitative physical science course like a chemistry. And I know you chemistry and physics teachers relate. Like if you were thrown a life science, you would be like, what am I doing? So I think it's when we jump across different disciplines that we get really overwhelmed. But chemistry, I really, really love as a subject matter. And so I wanted it to feel approachable and relatable to both students and teachers. We'll talk more about the teacher stuff later. But for students, I knew that so many students that take chemistry are never going to take potentially another science class again, other than maybe like a gen ed requirement in college. And most likely then they're not going to be picking chemistry. But they're taking chemistry because they're required to graduate high school. And so I wanted it to still be a course that really benefited them. And I knew that it could be. And that is because when it comes down to it, I fully believe that chemistry is a subject that's all about problem solving. It is a problem solving course. When we are teaching chemistry content, we are really teaching our students how to think critically and how to solve problems. Is there a good bit of math integrated within there? Yes. But if we teach our students how to be critical thinkers and problem solvers, they can handle any of that math that does come up. And that critical thinking and problem solving skill is a skill that's going to translate to any other subject that they take. This is what I love about chemistry. The other thing I love is that the micro truly informs the macro in chemistry, which I see that so much in biology too. But what is happening at this atomic and subatomic level, it's dictating what we see going on in a chemical reaction, in the physical properties that we see a material have. And I want students to understand this because I just think it helps us appreciate so much more the complexity of all things, living and non-living. And also just to see again how they can kind of be these investigators, these critical thinkers that see something really broad or really big, and how can they work backward to understand it from a micro level. I just think that's a really cool thing that we get to do in chemistry. And I genuinely think it's one of those subjects that the skills do translate to so many other courses that they'll take in their lives. So that's kind of my excitement behind chemistry and why I think you should be excited to teach it if you just got assigned to teach it. Now let's talk about sequence. So I kind of alluded to this in the intro, but when I started preparing to write this curriculum, I read hundreds and hundreds and hundreds of pages of state science standards. I reached out to my audience and I said, hey, send me the standards that you use in your state and also like where you teach. And you would think I only read 50 state standards, but there are many different schools using different versions of standards in different states. So it wasn't so cut and dry. Even the states that say that we've adopted the NGSS. If you know the NGSS, you know that the standards are divided up between physical science, life science, earth and space science, and the ETS standards. And it's not so cut and dry. It doesn't necessarily say these are the ones that you'll teach in chemistry. And while HSPS 1 and HSPS 3 are the more chemistry-based physical science standards, different states, different districts, different schools have kind of grouped those NGSS up differently. So it's just not so simple as in terms of everyone's teaching this. So I spent months reading standards and taking notes and then deciding upon the sequence that I do. So I have kind of 2 semesters of chemistry because it's a full year course, what I wrote. The first semester is the most foundational. Like I tell everyone for chemistry, I recommend slow and thorough and deep as opposed to going faster and covering everything just a little bit. Like I think the first 5 units in chemistry are the most critical. And then you can kind of decide how you want to mix and match in your second semester in terms of what units you want to cover. So first, I have my introduction to chemistry unit. And this is where I really debated because there's a lot of people that say like you should have a unit 0 where you introduce them to the math skills. There are other people that say dive right into content and just bring the math up later. I personally have found that I like starting out with some sort of introductory foundational unit because there's a lot of other things that I'm trying to teach in my classroom other than just content in that first unit. I'm really trying to set the tone for my class. I'm trying to teach procedures. I'm just trying to teach the rhythms. I'm trying to get to know students. So I like to have that foundational unit. And I want students to see from day one that chemistry is a problem-solving and critical thinking course. So I want to introduce those math skills immediately because that's just such easy fruit to grab off the tree in terms of thinking about ways to get them problem-solving. It's harder to like start with them learning about the periodic table and get them to see it as a problem-solving course, although the patterns and stuff there are amazing. So I like to start with exposing them to that right away and then bringing up the math over and over again throughout the year. I also feel like, and I've said this about every course, my students have the most energy and the least apathy at the start of the year. It's only going to get worse from here, you know? So I want to start out with harder things while they're freshly rested from summer and then kind of, you know, maybe loosen things up a little bit after that. And I also personally, I don't want the first time they're seeing conversion factors to be during stoichiometry when we're doing things like grams to moles. I would much rather them feel familiarized with conversion factors, talking about inches and meters and cups and milliliters than these units that are like so abstract to them. Like a mole is such a crazy thing for them to have to try to understand. And also, I understand that not all of my students will have taken physical science where we introduce this the first time. So my introduction to chemistry unit, we're covering measurement skills, dimensional analysis, and scientific notation, which will come back again at the start of semester 2 when we do STOIC. And then we're going to do an introduction to matter, classification, properties, that kind of stuff. Really like the basic stuff that I would hope if they had taken physical science with me that they've already seen, and we're just kind of refreshing at the beginning of the year. I will also say this too. I don't know how you introduce the mole or talk about the electromagnetic spectrum with flame tests if you haven't already covered scientific notation. And so I like to, yes, review measurement and lab equipment and all of that stuff that they've already seen, but I'm also wanting to make sure they've seen scientific notation and make sure my honor students know about sig figs and things, because this is all going to just keep coming up over and over and over again. My second unit is the atom, and we cover atomic theory and structure, the periodic table, but very basic, and nuclear chemistry. And then in unit 3, we do electrons, and we kind of do an overview of electrons, electron configurations, and then we get into periodic trends. Now, I think people might find it intriguing that I mentioned the periodic table in my second unit, the atom, but I don't get to periodic trends until my third unit. And I did this intentionally because I really want students to understand the atom before they start looking for trends. At the same time, I don't think you can introduce the structure of an atom without looking at the periodic table, and which is why the basics of the organization of the periodic table get introduced in that second unit. We're going to build on that later with periodic trends. This kind of scaffolding of like introducing ideas, building on it later. You've now heard me talk about this twice. This is a huge theme of this curriculum and of this course for me. Introducing a concept, circle back to it later and build upon that. All of this is so interconnected. So I know there's a lot of different ways you can do that, but I find that to be a helpful way to do it. I also like to go ahead and do nuclear chemistry in my second unit, the atom, because again, we've been talking about the structure of the atom, what makes up the nucleus. It just feels like a natural time to bring it in. And it also is a really interesting topic. And so I'm always trying to introduce interesting things into content that might be a little bit more boring. And I think nuclear chemistry is really interesting. And the structure of the atom, to me, is interesting, but not so much to a high schooler. So I like to integrate that there as well. And then I like to have the atom unit separated from electrons just because that's a lot of content to have a 1 mega unit, which is why I separate those into 2 smaller ones. Then we transition to unit 4, chemical bonds, which is definitely a mega unit. It's double the normal amount of concepts or content that I would teach. It's 6 concepts, and I do test those summatively separately, but I just found it was important to put all of these things together because I think students seeing the intermolecular forces alongside intramolecular forces as we're learning about bonds is really helpful. However, just like in biology, I do not want to teach mitosis and meiosis together. I want to teach them separate. I like that this is a bigger unit because I can separate out like ionic and covalent and some of these other things a little bit more within the scope of the larger unit. Okay, so here's what I mean by that. The first half of the unit 4 chemical bonds is an introduction to bonding and all just about how bonding is a spectrum. Then we get into ionic bonds and naming rules there and writing chemical formulas, and then metallic bonds. I test solely on that so they can really get those ionic bonds like squared away. Then the second half of the unit, we talk about covalent bonds and those naming and writing formula rules. We add on to that with molecular geometry and then intermolecular forces. Again, intermolecular forces is a tricky one. It could go in so many units, but I just want to introduce it as early as possible so that then I can bring it up again and again. So that is why I put it in this unit. I think it really serves students best in keeping the naming rules straight when the compounds are not all mixed together and I'm not having one big test on ionic and covalent and all these things put together. So that's why I like to kind of split that unit into 2 halves. Then we're going to end our first semester with Unit 5, chemical reactions. In this unit, I cover writing and classifying reactions as well as chemical equilibrium. And I will be honest, y'all, I went back and forth about when and where I wanted to put teaching chemical equilibrium. This is again one of those topics that could go a bunch of different places. But ultimately I decided let's bring it up early and introduce it, and then we can refer back to it in later units like Unit 9, acids and bases, Unit 10, thermochemistry. So that's what I settled on. That is how we wrap up our first semester. Then when we come back for semester 2, we kick off Unit 6, stoichiometry. And I like this because, again, we're coming off of a break, a little bit of time to recharge. We're going to bring up stuff like dimensional analysis and scientific notation that they've already seen before. So that's going to be a little bit familiar before we start learning it on this whole new level with meeting the mole, introducing stoic and limiting reactants and all that jazz. The other thing I like about doing this in January is that my personal stoichiometry unit has so many food-based activities. I joke that I wanted to make the content more palatable, pun intended, by doing that. But I think it's like a fun thing to do when it's cold, when it's dreary, we're all cooped up inside and we're learning harder stuff. Let's have some like fun hands-on resources where we're getting to eat different things and use food. And that feels fun. I like to couple hard content with things that feel fun. So that's why I like to kick off semester 2 with stoichiometry. Now, from there, I really feel like if you can get through those first 6 units, then you can kind of decide the order of the last 4. Do you want to do states and then acids, bases, solutions and states, then thermo? Like it's kind of up to you. But I really think those first 6 units are the most important. I personally would then go from stoic into unit 7, states of matter, talking about states, phase changes, and gas laws. Then I would transition to unit 8, solutions, types of solutions, concentrations, properties. Then acids, bases, defining, describing, reacting them. And then lastly, thermochemistry, talking about reaction energy, reaction kinetics, stuff like that. I like doing thermochemistry last because I feel like it is such a great way to tie in everything you've learned from every other unit. I know some people like to separate kinetics from thermodynamics, but I feel like kinetics is an easier topic. It's one that I already introduced my students to in physical science, and I think thermodynamics is trickier. So I like to pair harder things with easier things. I also like to end the year with thermochemistry because it is such an important topic if they go on to take AP chemistry. So I like that it is a little bit more fresh if then we finish the year in May with this and they come back in August and pick up with AP Chem. I also like if they're going to go on to take AP Biology. I feel like it's like an important topic to be familiar with going into that science. So I just personally like to end the year there. So that is my sequence. That's how I've kind of grouped the topics. Now, here are some of those themes I talked about that are woven throughout multiple units that we introduce once and then we're going to bring up over and over again. First is that idea that bonding is a spectrum. And this is something right now as I'm rewriting my physical science curriculum, I'm done with all the physics-based units and I'm on the chemistry-based ones. I am making sure that this too is a theme that comes forward. This idea that it's not just cut and dry, ionic versus covalent versus metallic, that there's this range of strength in terms of what we would see happen. And that's why we see quote unquote exceptions to the rules, because again, it's a spectrum. It's not just these categories of bonds. Also, I think another great theme is that everything in chemistry comes down to electrons and really electronegativity. That's why I love having a unit entirely about electrons. I think they are not highlighted as much as they should be in terms of how critical they are. We often talk about the protons and that the identity of the element is based on the protons that it has in its nucleus. And that's true. But so much about how an atom is going to behave is going to be because of those electrons and electronegativity differences. So that's a really important theme that's going to come up over and over again. Collision theory, for sure, kinetic molecular theory, and intermolecular forces as well. All things that cover multiple units. So what makes It's Not Rocket Science chemistry unique? The first thing is what I just said, is those themes. I love writing curriculum holistically, meaning I'm writing the whole thing all at once. I'm not just piecing together things as I go. And because I do that, I'm so incredibly intentional and strategic about what I'm doing and making sure that these themes do get brought up over and over again. That is the beauty of writing a curriculum, quote unquote, in one sitting, is I'm like very clearly weaving these ideas throughout the entire tapestry of a whole year's worth of instructional resources and not just kind of like throwing things together. I'm also making sure that every instructional resource aligns to the assessment questions that we're going to be assessing students on, so that again, we're not just doing activities and taking notes for the sake of doing it. It's all purposeful and intentional so that we're teaching critical thinking, we're teaching problem solving, and we're covering all these themes that I just mentioned. Another thing I love about It's Not Rocket Science chemistry, but really all It's Not Rocket Science curricula, is the variety of instructional resources. This is another perk of writing curriculum holistically. It's that I'm looking at the whole unit at once and then looking at this unit but compared to the ones before and after and saying, okay, do we have inquiry activities? Do we have hands-on labs? Do we have stations? Do we have research? Do we have reinforcing practice? Do we have lecture notes? Like I'm making sure every unit has all of this variety in it so that it's not just this ho-hum, come in, take notes, do practice problems, repeat until the test, have a lab once a unit, call it a lab-based science and call it a day. We're switching up the learning style and switching up the way we're approaching these complex concepts with students to engage them. Yes, there are some chemistry classics in my curriculum. I've got the colligative properties ice cream lab, my version of it. I've got my version of a flame test lab. But at the end of the day, I wanted to do my own instructional resources, my own ways of helping you approach these topics on top of just the classic chemistry ones that we all kind of know and love. As I mentioned at the top, one of my main goals was that this curriculum would be approachable and relatable for students, but also teachers. And that's why one of the things that makes this curriculum so unique from anything else I've seen of chemistry curriculum out there is the intentionality of the support that's included in it. I wrote this for the biology teacher teaching chemistry for the first time. I really prioritized, based on y'all's feedback, lab setup pictures, videos of me demonstrating different labs and different things that you should see, and comprehensiveness when it comes to the answer keys. When you pull up an It's Not Rocket Science chemistry answer key, it's not just going to say, 10 grams per mole. It's going to have the entire problem typed out clearly, not even handwritten like I used to. And there are hundreds and hundreds of pages of teacher notes. Also, this curriculum is unique because I really wrote it for the teacher with no lab space or traditional supplies in mind. I know what it's like to teach a lab-based science in a non-lab space. It is so challenging. So no labs require Bunsen burners or gas. If there's a lab where you could use that, like the flame test, then I provide options for you to do so. But typically I'm saying like, hey, here's how you're going to be able to do it without all these things. All of the lab materials can be ordered from online retailers, and I constantly prioritize low budget items for the teacher who does not have a science budget, because I fully believe your students can learn chemistry in an experiential, hands-on way without you breaking the bank. And it doesn't just have to be kitchen chemistry. Yes, kitchen chemistry is in there and that's great, but we can use other chemicals and things like that too and give your students some really rich experiences no matter your teaching environment that you're in. The last two things I'll say is that I really feel passionate about meeting a variety of learners' needs. That's why when you buy any of my resources, you're getting the college prep on grade level resources and the honors resources all in one. I'm not requiring you to pay separately for those two things. Also, every set of notes, CP and honors, comes 3 ways: a very open-ended outline, a fill-in-the-blank version, and a completely filled-in version. You've got lecture videos on my YouTube channel now that anyone can access if you want to flip your classroom. And then on top of that, I included differentiation guides that I added about a year ago that go into extreme detail for how you can continue to differentiate the included resources to better serve a variety of learners. So there's so much support here so that you feel equipped to teach this and teach it in a way that is not going to drain you and actually be fun for you and your students. The last thing I'll say is the organization and the alignment is unmatched. I am psycho about organization, and it's something I really, really care about. And you will not find a curriculum from a textbook company anywhere that is this organized or this human, okay? You can reach out to me anytime and talk to me and ask a question about a lab, ask for clarification. Like, I am here to help you. You are not going to have to go through like a ChatGPT AI customer service robot to get to me. I have another human, Allison, who helps me with email. So she often will answer questions first and then come to me for the ones she can answer. But you're still, whether you're talking to Allison or me, you're talking to a human being first. And I just think that's so, so important. Okay, your take-home challenge. If you teach chemistry, I have a free download of my scope and sequence, my pacing guide. You can grab it at itsnotrocketscienceclassroom.com/chemistry guide. This could be helpful for anyone, whether or not you use It's Not Rocket Science curriculum. That is not a requirement or a prerequisite to be able to use that pacing guide. So make sure you grab that. And if you want to check out other episodes I've done on other topics, episode 209 is my anatomy scope and sequence. Episode 220 is biology. And I'll be recording one of these for physical science as soon as I finish my revamp. You can find the show notes at itsnotrocketscienceclassroom.com/episode 232. All right, teacher friends, that wraps up today's episode. If you're looking for an easy way to start simplifying your life as a secondary science teacher, head to itsnotrocketscienceclassroom.com/challenge to grab your classroom reset challenge. And guess what? It's totally free. Thanks so much for tuning in, and I'll see you here next week. Until then, I'll be rooting for you, teacher friend.